You drink milk from a cow without a second thought. It's in your coffee, in your cereal, in the cheese on your pizza, in the butter on your bread. Cow's milk has become so embedded in global food culture that it barely registers as a choice. It registers as a default. Milk means cow's milk the same way egg means chicken egg and meat. In many contexts, effectively means beef or chicken. But here is the question that almost nobody stops to ask. Why cow? Out of every mammal on the planet that produces milk, and there are more than 5,000 species of mammals, every single one of them producing milk for their offspring, why did one species of bovine become the universal dairy animal? And the follow-up question, which is where it actually gets interesting, do we drink other animals' milk? And if so, which ones, and why those? Because it turns out we do. Quite a few of them. And the reasons why some milks became global staples while others stayed regional specialties. And why the vast majority of animal milks are never consumed by humans at all, involve biology, economics, domestication, history, and some surprisingly consequential decisions made by ancient farmers in the Fertile Crescent several thousand years ago. Let's go through this properly. Start with the biology of milk, because the first thing to understand is that milk is not one substance. The word covers an enormous range of biological compositions that differ significantly between species in ways that affect their taste, their nutritional profile, their behavior when processed, and their suitability as food for a species that didn't evolve to consume them. Milk is produced by the mammary glands of female mammals to nourish their offspring during the period before the young animal can sustain itself on other food. It is, biologically speaking, a complete food. Designed to contain everything the offspring needs to grow rapidly from a dependent neonate to an independent juvenile. The specific composition is calibrated by evolution to meet the specific developmental needs of the specific offspring, which means that the milk of every species is somewhat different from the milk of every other species. The primary components of milk are water, fat, protein, and lactose, the sugar specific to milk. The ratios of these components vary substantially across species. Human milk is approximately 3.8% fat and 7% lactose. Cow's milk is approximately 3.7% fat and 4.8% lactose. Seal milk is approximately 50% fat because seal pups need to rapidly accumulate a thick layer of blubber for thermal insulation in cold ocean environments. Whale milk is similarly fat-rich. The milk is calibrated for the physiology of the animal that will consume it. This calibration has practical consequences for human consumption. Human infants consuming cow's milk formula rather than human milk are consuming a product with a different protein-to-fat ratio, a different lactose concentration, and different specific protein types than the milk their physiology was designed for. This is manageable with appropriate processing. Infant formula is modified to approximate human milk composition more closely. But the differences are real and nutritionally meaningful. Now let's talk about lactose. Because lactose is the key to understanding who can drink which milks and why this matters enormously in the history of dairy consumption. Lactose is a sugar that requires an enzyme called lactase to digest. Lactase breaks lactose into its component sugars, glucose and galactose, that can be absorbed by the gut. Without lactase, lactose passes undigested into the large intestine, where gut bacteria ferment it, producing gas, bloating, and the other symptoms of lactose intolerance. All mammal infants produce lactase. They need it to digest their mother's milk. In most mammal species, lactase production is downregulated after weaning because after weaning there is no milk to digest and maintaining the enzyme is metabolically costly when it serves no function. In most human populations until relatively recently, the same thing happened. Children could digest milk, adults couldn't. Drinking significant amounts of fresh milk as an adult produced uncomfortable gastrointestinal symptoms and was therefore not particularly attractive as a dietary practice. This changed approximately 10,000 years ago in certain human populations through a genetic mutation, technically a mutation in the regulatory region near the lactase gene that kept the lactase gene switched on into adulthood rather than being downregulated after weaning. This mutation, called lactase persistence, allowed adult carriers to digest lactose without symptoms. It spread rapidly in specific populations, European populations primarily, and certain African pastoralist populations through natural selection, because in a context where dairy herds were available, the ability to extract nutrition from fresh milk as an adult was a significant survival advantage. The distribution of lactase persistence globally is striking. In Northern European populations, lactase persistence reaches frequencies of 90% or higher. Most people of Northern European ancestry can drink fresh milk as adults without problems. In East Asian populations, lactase persistence frequencies are typically below 20%. In sub-Saharan African populations, the picture is mixed. Some pastoralist groups like the Maasai have high lactase persistence frequencies, while agricultural groups have lower frequencies. The distribution maps almost perfectly onto the history of dairying. Populations that kept dairy animals for long periods have high lactase persistence, populations that didn't have lower frequencies. This is co-evolution in real time. The humans and their dairy animals were changing each other simultaneously, the animals being shaped by selective breeding toward greater milk production, and the humans being shaped by natural selection toward the ability to use that milk as adults. This is one of the most clearly documented examples of recent human evolution driven by cultural practice, and it happened in a blink by evolutionary standards. Approximately 10,000 years is nothing in the context of the millions of years of human evolutionary history. This genetic history shapes which populations can most easily use fresh animal milk as a major dietary component. It doesn't determine the answer. Lactase persistence is not required to use dairy because fermented dairy products like cheese, yogurt, and butter have much lower lactose concentrations and can be consumed by people without lactase persistence. But it shapes the dietary landscape in which dairy became important for some populations and not others. Now let's talk about which animal milks are actually consumed by humans, because the answer is broader than most people realize. Goat's milk is the second most consumed animal milk globally, and the gap between its consumption and cow's milk consumption is smaller than most people in Western countries realize. In many parts of the Mediterranean, the Middle East, and sub-Saharan Africa, goat's milk is more commonly consumed than cow's milk. Goat's milk has a slightly different protein structure from cow's milk. The fat globules are smaller, and the protein structure is different enough that many people who experience digestive discomfort with cow's milk tolerate goat's milk more easily, though the lactose content is similar. Goat's milk cheeses, feta, chèvre, many Spanish and Italian varieties, are produced and consumed across a huge geographic range. Sheep's milk is the third most widely produced animal milk for human consumption. Sheep's milk is significantly higher in fat and protein than cow's or goat's milk, approximately double the fat content of cow's milk, which makes it particularly well-suited to cheese production, where higher fat content produces richer, denser cheeses. The most famous sheep's milk cheeses include Roquefort, Manchego, Pecorino Romano, and feta in its traditional Greek form. Sheep's milk is rarely consumed as fresh liquid milk because the high fat content makes it extremely rich, and because sheep are simply less productive than cows in terms of raw volume. Camel's milk is consumed across the Arabian Peninsula, North Africa, Central Asia, and parts of East Africa, in environments where camels are the primary large domesticated animal, arid and semi-arid regions where cattle are not viable. Camel's milk has been a dietary staple for thousands of years. Camel's milk has a distinctive composition: lower lactose than cow's milk, higher vitamin C, different fat profile, and is consumed both fresh and in fermented form. The Somali and other East African pastoralist cultures have historically derived substantial nutrition from camel's milk in contexts where cattle would not survive the climate. Yak's milk is consumed across the Tibetan Plateau and surrounding high-altitude regions. Yaks are well adapted to the extreme conditions of high-altitude environments where cattle cannot survive, and yak's milk is substantially higher in fat than cow's milk. The fat content is typically above 7%, compared to cow's milk at around 3.7%. The extra fat is adaptive for calves that need to maintain body temperature in extreme cold. For humans, it produces a very rich milk that is used to make yak butter, a central component of butter tea, the traditional beverage of Tibetan culture, which is made from tea, yak butter, and salt. The high caloric density of yak milk and its products is directly adapted to the caloric demands of high-altitude cold climate living. Horse's milk, specifically mare's milk, is fermented into a mildly alcoholic beverage called kaumis across Central Asia, from Kazakhstan through Mongolia. Kumis has been a staple food of the Central Asian steppe nomads for thousands of years, and remains an important food in those cultures today. Mare's milk has high lactose content, which makes it well suited to fermentation. The lactose is converted by bacteria and yeasts to lactic acid, and a small amount of alcohol, producing a tangy, mildly fizzy drink that is nutritious, partially preservable, and, importantly, lower in lactose than the fresh milk it is made from, making it accessible to people without lactase persistence. Reindeer milk is consumed by indigenous peoples of northern Scandinavia and Siberia. It is extremely rich. Reindeer milk contains approximately 22% fat, reflecting the caloric demands of reindeer calves that must rapidly accumulate energy reserves in harsh subarctic conditions. It is not produced in large volumes because reindeer are smaller animals than cattle and produce smaller quantities of milk per animal, but within the cultures that keep reindeer, it is a valued food resource. Buffalo milk is important in South and Southeast Asia. Water buffalo milk is higher in fat than cow's milk and is used to make mozzarella di bufala, the traditional mozzarella of southern Italy, which has a richer flavor and creamier texture than cow's milk mozzarella precisely because of the higher fat content. In India, water buffalo are actually the primary dairy animal in many regions, with buffalo milk production exceeding cow's milk production in some states. Donkey's milk is one of the lesser-known animal milks consumed by humans, but it has a history that extends back to ancient Rome and Greece, where it was prized for both its nutritional properties and its purported skin benefits. Donkey's milk has a composition closer to human breast milk than any other commonly available animal milk. Similar lactose levels, similar protein content, different fat profile. This similarity to human milk made it historically used as a substitute for human breast milk when wet nurses were unavailable. In modern times, donkey's milk has attracted interest as a specialty food and as an ingredient in cosmetics, where its composition is marketed as particularly beneficial for skin health. Now let's talk about how milk is processed, because fermentation and processing transformed milk from a beverage that most adults couldn't digest into one of the most diverse food categories in the human diet. And this transformation is the reason dairy became so central to so many food cultures despite widespread lactose intolerance. The earliest dairy processing was probably accidental. Milk stored in pouches made from animal stomachs, which contain residual rennet, the enzyme complex that causes milk to coagulate, would have curdled into something resembling soft cheese. The discovery that curdled milk was edible, storable, and in some ways more useful than fresh milk was probably made independently in multiple locations by the early farmers and herders who first kept dairy animals. The crucial practical consequence of fermentation and coagulation is lactose reduction. When milk is converted to yogurt, the bacteria doing the fermentation consume lactose and convert it to lactic acid. When milk is converted to hard cheese, the whey, which contains most of the lactose, is drained away, leaving a product that is dramatically lower in lactose than the original milk. Hard-aged cheese like Parmesan or aged cheddar contains essentially no lactose, making it digestible even by people with complete lactose intolerance. This means that the development of dairy processing technology dramatically expanded the population of people who could benefit from dairy, independent of the lactase persistence mutation. Long before lactase persistence had spread to significant frequencies in European populations, people were consuming fermented and processed dairy in forms that didn't require lactase. The cheese and the yogurt came before the genetic adaptation that made fresh milk easily drinkable. The implication is that dairying and the human lactase persistence mutation co-evolved in a more complex relationship than simple cause and effect. It wasn't that lactase persistence allowed dairying. Dairying was established through processed dairy products first, and then the availability of fresh milk as an additional nutrition source selected for lactase persistence in populations where the herds were already present. The question then is why, given this diversity of animal milks that are consumed in various parts of the world, cow's milk became so dominant globally. The answer is not that cow's milk is nutritionally superior to these alternatives. It isn't, in any straightforward sense. Sheep's milk has more fat and protein. Yak milk has more fat. Camel milk has more vitamin C. Donkey milk is closer in composition to human milk than cow's milk. The answer is about scale, geography, and the specific characteristics of cattle as domesticated animals. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Cattle are large. A single cow produces vastly more milk than a sheep, a goat, a yak, or a reindeer. A high-producing dairy cow can produce 10,000 liters of milk per year. A sheep produces 200 to 400 liters per year. A goat produces 500 to 800 liters per year. The volume difference is enormous. For the purposes of feeding large settled populations in temperate agricultural zones, the specific context in which early European civilization developed, cattle offered a milk volume per animal that no other domesticated species could match. Cattle are also adaptable across a wide range of temperate agricultural environments. They can graze on pasture land that is not suitable for crops. They convert grass, a resource that humans cannot directly digest, into milk and meat. In the specific ecological context of European agriculture, where significant pasture land existed alongside arable land, cattle were an efficient way to extract nutrition from land that couldn't be cultivated. Now let's address the milks we don't drink, because this is the most interesting part. Why, out of more than 5,000 mammalian species, have humans limited themselves to milks from perhaps a dozen? The answer is domestication. Producing milk from an animal requires keeping that animal in proximity to humans, managing its breeding, handling it regularly enough to milk it, and maintaining a herd large enough to sustain continuous production. This is only feasible with animals that are domesticable, that tolerate close human contact, that breed under human management conditions, that don't pose unacceptable safety risks to handlers, and that are productive enough in terms of milk volume to make the management effort worthwhile. Most animals are not domesticable in the relevant sense. Lions produce milk, rich, fatty milk that would theoretically be edible. But trying to milk a lion is not a viable agricultural strategy. Elephants produce milk, but are not docile enough to milk regularly, and female elephants with calves are among the most dangerous animals to approach. Moose have been experimented with as dairy animals in Scandinavia, and moose milk is extraordinarily fat-rich, but moose are difficult to manage at scale, produce limited volumes, and have not proven economically viable as dairy animals despite multiple attempts. The zebra is worth mentioning because it is closely related to the horse, which has been successfully used as a dairy animal. But zebras have been essentially impossible to domesticate. Multiple serious attempts across history have failed. The zebra's temperament, its specific fear responses, and its behavioral patterns have consistently resisted the domestication process that transformed the horse into a manageable animal. Zebra milk exists. Nobody is drinking it because nobody has managed to keep zebras in circumstances where regular milking is possible. The kangaroo produces milk of extraordinary compositional complexity. Different stages of joey development require chemically different milk, which the mother produces simultaneously from different mammary glands for joeys at different developmental stages. It is one of the most biochemically interesting milks produced by any mammal. It is also produced by an animal that is not domesticated, and that produces it in quantities calibrated to feed a joey, not a human population. The animals that provide human dairy globally share a cluster of characteristics: relatively docile temperament when properly habituated, willingness to continue producing milk beyond the needs of their own offspring when managed correctly, adaptability to confinement or management in herds, and sufficient milk volume to justify the effort. This cluster is relatively rare among mammals, which is why the list of dairy animals is so short relative to the total number of mammalian species. The European colonial expansion of the last 5 centuries exported not just European people and European languages, but European agricultural systems, including the cattle-based dairy system that those agricultural systems depended on. Cattle were introduced to the Americas, to Australia, to parts of Africa and Asia where European settlers established farms. The global cow's milk supply chain that we now treat as a default was built primarily by European agricultural practices spreading globally over 5 centuries. Before that expansion, many of the regions where cow's milk is now standard had different dairy traditions, or no significant dairy tradition at all, that were displaced or supplemented by the arriving cattle culture. And this is ultimately the answer to the question in the title. We drink certain animals' milk because those are the animals with the specific combination of domesticability, milk volume, geographic availability, and historical timing of domestication that brought them into the human food system at the right moment and in the right place. We don't drink the milk of most animals not because their milk is inedible, but because those animals are not domesticable at dairy scale, or because they occupy geographic ranges where the human cultures that encountered them had already developed alternative food systems, or because their milk volumes are too low to make the management effort worthwhile. The global dominance of cow's milk is not a biological verdict on its superiority. It is the product of specific agricultural decisions made in specific places at specific times in history, amplified by European colonial expansion and the global food system that followed. Donkey milk is closer to human milk than cow's milk. Yak milk is richer in fat than anything in a standard supermarket. Sheep milk is so concentrated in nutrition that a small volume outperforms a large one. Camel milk survives without refrigeration in environments where cow's milk would spoil within hours. Reindeer milk is so fat-rich it's essentially cream from the first pour. These milks exist. People drink them. They always have in the places where the animals lived and the cultures that developed around them. The milk in your coffee is an accident of history, wearing the disguise of inevitability. And somewhere in Central Asia right now, someone is drinking fermented mare's milk and thinking absolutely nothing unusual about it.